Well, let's see, in about a week we're going to do QRP to the field. That's the QRP TTF exercise or program. As most of you know, we do this every year. It starts off kind of like a picnic and whatnot, but QRP TTF is actually an event that happens across, at least around the United States. The actual event runs from about 6 o'clock in the morning local, or no, 8 o'clock in the morning local time to about 6 o'clock in the afternoon local. This year they have a theme to it, which is called The River Runs Through It. So people take their QRP transmitters, which are the low power transmitters, they go out in the field, set it up in a park or something that has a river through it, and they use the exchange of the signal report, the state they're in, and the river. Well, we don't have a river running through our park, so we are classified as a field station. So we're going to be doing the RST, Vienna, and then the name, which we'll probably use Pat, I assume. But anyway, that gives us a chance to take any low power transmitters that we have, set them up in the park, and go ahead and operate on the HF or any of the HF bands. This year we're doing we're going to add something to that, because only about 3 or 4 people may actually have transmitters running, and you may have 15 or 20 people out in the park. So what I did is I'll explain a little bit more about it, but what I did is I decided to add a hidden transmitter challenge for people that have a 2-meter rig, so that they can try to find some transmitters that I'm going to hide around the park. I've got a presentation that I'm going to run. This is going to be narrated. It's almost like a video, if you want to call it that. But this will explain more about it, and go ahead and watch it and you'll see what happens. Okay, welcome to the QRP Hidden Transmitter exercise. This is a presentation done for the Vienna Wireless Society by Mel, KI4WKZ. So let's get started. A little bit of background. QRP, as most of you know, is a Q code for low power operations. In this example, the transmitters will be running at about 15 milliwatts, which is truly low power. We had some old transmitters that were used several years ago for a fox hunt activity, and they were found in our storage locker. These transmitters have been repaired, they've been reprogrammed, and they've been made ready for this operation. So what's needed to find the hidden transmitters? Well, basically you're going to need a handy-talkie, set it for 147.455 megahertz, narrowband FM, receive only. You'll need a directive antenna or a directional antenna. It's very much desired, and we'll explain a little bit more about that later. A compass will be very handy when operating out in the park in order to get a bearing that you get from your antenna. You'll need a map of the area, and we'll be providing that. This will be a map of the park that we'll be operating in. If anybody has any other direction finding equipment that they'd like to bring to the QRP and to the field activity, just to have for show and tell, that would be fine. Or even if you have something that you'd like to try and locate the hidden transmitter, you can do that too. All of these transmitters are going to be operating on the K4XY call sign. I'm going to be explaining a little bit about some simple antenna options. I'll introduce the transmitters. We will select one of those transmitters and an antenna to do a graphical demonstration, so we can do that in this presentation. While we're doing that, we can also explain the strategy we use to find the transmitter using one of these antennas. Also, at the end of the presentation, I'll show you a map of the area that we'll be using. And if you're interested, there will be an optional scoring if you'd like to compare your results in the event that you'd like to do it, maybe more than once, or simply to compare your results to somebody else. Now, the antenna options, there's a few different ones that you can use. These are all fairly simple antennas, and we're not getting into direction finding equipment or anything like that. These are just things that you can use with an HT directly. Probably the most popular, the one that a lot of people use, are the Yagi antennas. The Yagi has a directive pattern where it has a strong beam in the front, and it has a very weak lobe in the back of the antenna. We can actually use this to our advantage while we're trying to locate these transmitters. So this is one good option that somebody could try. Another one is the loop antenna. This is actually a view of the loop looking down on it, so that's why it looks a little flat. But it basically has a figure 8 pattern when viewed this way. But the most important part about the loop is actually that it has a null in the direction perpendicular to the plane of the antenna. And that can be used to great advantage when trying to direction find. This is a half-wave dipole. It has a figure 8 pattern when viewed from the top like this. And it has a null right off of the ends of the wire. Now, unfortunately, because you're so close to the ground, if you were hand holding this antenna, you'd probably only be 4 or 5 feet above the ground. So this pattern really becomes more omnidirectional. It may not be useful for direction finding activity. This is just your standard whip antenna. You can imagine this looking straight down on it. So it has an omnidirectional pattern. With the omnidirectional pattern, you probably wouldn't be able to use it for direction finding the way it is, or the way it's shown. However, one thing you can do is to put yourself near the antenna and block the pattern in one direction so that the back side becomes a null, whereas the front side becomes the normal signal coming in from some source. This will give you a simulation, if you will, of a pattern which looks a little bit like the Yagi, but not quite as good. But it might be possible to use this as a method of finding the transmitters. Now, the actual transmitters, we're going to introduce those one at a time. There's 5 of them. They'll be located out in the field in different places. This is their first transmitter. This is MOE. So he's going to be sending a Morse code call sign of the K4XY followed by his identification. And it'll sound, the identification is going to sound a little bit like this. Hi, Det. And anyway, he's going to be one of the transmitters out in the field. Now, the most important character on these identifications is going to be that last character. And you'll see how this develops here in a moment. So he's going to be the single DIT. Are you ready, DIT? Okay. Here's the second one. This is MOI. And we sometimes refer to him as DIT DIT. How you doing today? Okay. Oh, this is a little cutie. This is going to be MOS. So he's got she's got 3 DITs. And you doing okay today? No, you're not an I. There you go. You don't want to fool people. This will be probably MOH with the 4 dits. He's going to be helping us with a demonstration, so you'll see him a little bit later. By now you've probably figured out who this guy is. Yep, that's MO5. How you doing today? Okay. Anyway, the transmitters are all going to be out in the field, but they're not going to be transmitting at exactly the same time. Each transmitter will be running for about 1 minute. Then it'll shut off for a duration of about 4 to 5 minutes. So it'll be on for a minute. Then there's about a 10-second gap, and then the next transmitter will come on. The next transmitter will do his 1 minute of transmission, and then it'll go off for 10 seconds, and then the next transmitter will come on. And that pattern of 1 minute on and about 4.5 minutes or so off is going to repeat. The actual sequence you won't know. You'll have to discover that by listening carefully to the transmitters out in the field so that you know which one is which. Remember that last character with the dit, the 2 dits, 3 dits, 4 dits, and 5 dits are the clue as to who's who. So each transmitter at the end of the 1 minute period will send his call sign K4XY followed by one of these identification codes, the MO, and then the character or the actual identification of the transmitter. All these transmitters are going to be on 147.455 megahertz, and their transmitting is less than 15 milliwatts, which will give them a range of maybe 200 to 300 feet. So depending upon the conditions out in the park, we should be able to hear all of them in most places that we might put the transmitters. Okay, well, let's try an example of a strategy to find one of these transmitters. Now, MOH has volunteered to help us with this, so let's put him on the map here. Hi, how you doing up there? No, you're not 3. Okay, that's 4. All right. Anyway, he's going to be out in the field, and he's just going to be transmitting every minute, and then he'll go off for a little bit, and then he'll come back on again. Now, what you want to do is locate a couple of spots on the map that you want to use to do your direction finding. Now, on this example, I'm just going to place a couple of locations. They can be arbitrary, nothing critical about it. The only one thing that is critical is that you know where these spots are on the map. So just keep that in mind. On this demonstration, you're not going to see the map right away. So here's an example of the first location. Here's the second location. Probably the only requirement you want to make is that the distance between the two probably should be somewhere around 100 feet apart. It's not critical. It doesn't have to be that distance, but just to give you a suggestion on what you could try, because the park isn't very big, so you just need some significant spacing between them, and hopefully you're still within range of the transmitter you're looking for from these 2 different locations, which you won't really know until after you've been out in the park for a while. So let's bring our operator in and see if we can figure out what the strategy is he's going to use to find this transmitter. Okay, we've got an operator. He's going to be using the Yagi antenna, which is probably the easiest to understand because of the shape of the antenna and whatnot. Now remember that it's got gain in the forward direction, and it's got a null or a very low gain on the back. We're going to use that to an advantage here while we're locating the transmitter. from where he's standing right now, he may actually be able to hear the signal from the transmitter. He's got a little bit of gain in that direction. He might be actually picking it up, but he doesn't really know where the transmitter is yet. So let's put him on one of these blue spots, and we'll go from there. So now he's at a known location on his map. He's picked this out previously so that he can use it. The way he's pointed right now, he's actually pointed towards the transmitter, so he may be hearing the transmitter, but he doesn't really know where it is yet. So he starts moving his antenna around, back and forth, and trying to locate the antenna, or locate the transmitter. Now the one thing about this Yagi is that the beam is not real sharp. It's got quite an angle to it. So his ability to actually say which direction that transmitter is coming from is not real good. So we're going to try a little experiment here and use the backside of the antenna to create a null. So here he's turned around, and he's got the null pointed behind him. So what he's looking for now is a weak signal, trying to make the signal as weak as he can and trying to determine where the transmitter is by the null, rather than trying to make a strong signal, trying to make a weak one in his receiver. So he'll move a little bit around. When he finally decides that he's got it pointed in the direction that he thinks the true null is, he'll then mark on the map from his location the direction that his antenna pointed and put a line on his map. Now he's going to move over to the other location and basically do the same kind of operation. Here again, he may actually be pointed off in the distance here, but he may receive the signal, but he's got to try to locate a direction that would be the bearing to that signal. One thing about the Yagi antenna, this is because it's close to the ground, sometimes the pattern gets distorted because of the proximity of the ground, and you may not be able to do very good direction finding with it in the horizontal position like he's showing it. What you can do is simply turn the antenna 90 degrees and hold it vertically, and you may be able to get a little better angle or a little better direction finding capability with it. So here he's moving around again, trying to find the strongest signal. And there again, you can see there can be quite a range of directions. So, he could be all over the place looking for it. However, if he turns around again, now he's searching for a null. Find the weakest signal rather than the strongest. Once he decides he's got a pretty good null, at this location, he'll then draw a line on the map that corresponds to the antenna direction again. And he just draws the line across the map. The point at which these two lines cross is most likely where the vicinity of the transmitter. So, how'd we do out there, H? Okay. Now, there's actually going to be 5 transmitters. From these 2 locations that you've marked on the map, you can probably locate all 5 transmitters using the same strategy that we've just demonstrated. For example, here's another transmitter. This is 5. He's out in this general area, as noted by these 2 lines. We'll call these the lines of position, which is really a a better term for them. Here's MOE. There again, he's got his lineup position from the two different spots. Here's MOS. He's got these positions. Oh, here's MOI. He's out at the intersection of these two lines, which actually goes from here to there, from there to there. So he's located all 5. Now let's take a look at the map of the park and get some ideas on how this is going to work in the actual world. We've put together a map that shows the park, which is this green area. There's a few landmarks on here that we can use. There's 2 parking lots, one down in this area. There's another one up in this area. There's a pathway that runs through the park. There's the restrooms are down in this area. This is a baseball diamond. These are tennis courts. This is a children's play area. This is a shelter where the picnic tables are. This is what they typically call the upper shelter. This is a larger shelter. It's a lower shelter. And then this is a small covered area down here where there's some picnic tables. Now during this experiment, all of the transmitters are going to be located within the green area. We're not going to go outside the park. On the map, I have placed a grid. The grid is somewhat arbitrary, but by using the grid locations and the landmarks, you may be able to discover where how this grid setup is designed. Anyway, there's sections A, B, C through H, and then you have 1 through 8 along the vertical axis. Up in the corner is a compass rose, which is pointed to true north. So if you have a compass and you're going to draw your lines on here, you remember to take into account that there is a small deviation for the magnetic compass versus the true north. Anyway, this is the map. What we're going to try to do is see if you can determine which grid quadrant the transmitters are located. For example, this spot right here would be C4, whereas this spot up here would be F5, and so forth. So you don't have to find these transmitters, with great precision. You just need to get the right general area. If you're locating your reference points, you could try different places along the pathway or at the shelters or wherever you want to do it. But you've got different options, and that's really up to you how you do it. Just as an example of what you could do to score yourself, the first item is really the transmit sequence of the Fox transmitters. What you place up here are simply the order in which you hear the transmitters. For example, if you heard MOE first, then this would be MOE. If the next one you heard was MO5, you could put that in here, etc., and fill these out. If you get it correct, and remember these are just looping around, so it doesn't matter which one you start with, it just if you get the right sequence. But if you get that sequence correct, you can give yourself 5 points. Now the nice thing is you can do this even while you're eating a hamburger with your HT. You don't even have to be out in the field much. So this is an easy one for you. The next one is, did you locate the transmitter into the correct grid square. So here you just put in the name of the transmitter, for example, MOE or MOI or whoever, and you say he's located in grid square, you know, C4 or F5 or whatever. If you get it correct, give yourself 10 points. You can try to locate all 5 of them, or as many as you can. Down here you get some bonus points if you get more than one correct. Let's say you got 2 correct locations and you could add 5 points. If you got 3 correct locations, you could add 10 points. And remember, these add up. So if you got 3, you've also got 2. So these will add up. You'll get a total score. The maximum score is 105. And that is about it. So I hope you all have fun and enjoy the event. Just as a little bit of follow-up on this, yesterday I went out to the park. I've located some, I've determined some locations to put the transmitters, so I already know where they're going to go. I don't know which order they're going to be transmitting in. That's for you guys to figure out. So anyway, that's the basis of this little activity, and it's just something that's going to be fun to do. That's all. It's not a contest. It's just actually it's a good training exercise for. It's a good training exercise for if you know people don't really have much of an opportunity to try to locate a transmitter in this manner, and so this will be a good chance to just practice. If you find a transmitter, just leave it where it is. But here's another thing. If you're walking through the park and you say, oh, there's one over there. Oh, I see one over there. That's, you can do that. You may even be successful at it. But if you don't have a radio, you're not going to tell who's who. So that's the important part of this too. Yes, sir.
Are the timers on those good enough that there's no danger of one catching up to and passing another?
That's an excellent question. The answer is no. Those the transmitters are the same transmitters which Pete mentioned, or that Lee mentioned that we used in Nottoway Park about 9 years ago. I've taken all those transmitters. I've gone through all of them. I fixed all the cold solder joints, fixed some parts that were in the wrong places and stuff, and got all the transmitters working in an identical manner. That was just the hardware part of it. The other part of it is that the software that's inside of these things has been completely redone, and getting the timing on these things has turned out to be a very tricky job because these transmitters do not have voltage regulators in them, so they depend upon the batteries holding their voltages up. To keep the timing, yes. The one thing I've been thinking about is that we'll do this little experiment and see how it works. If people are interested in us doing this again in the future, you know, maybe next year or something, we might reconsider using or redesigning these transmitters, putting some proper voltage regulators in them, and getting the timing a little bit better, because they are free running, like he mentioned, and they will have a tendency to drift over time. Now, the testing that I've done on them, the transmitters, I've run them for about 4 hours, and I've been able to keep them all separate. If you let them run for a long time, you know, 6 or 7 hours or something, they will tend to drift into each other. If you get 2 of them transmitting at the same time, it's going to get confused. But I can't guarantee that even during the time of this event that they won't drift into each other. So there are some technical issues involved with this little experiment too. But anyway, I'm just setting this up so that people that are interested can have something to play with.